This ALTAM Excel workbook converts one effective annual interest rate into the nominal rates, discount rates, and Woolhouse alpha and beta factors you need for MTHLY annuities. The only typed input is I equals 0.05 in cell C7. The sheet then fills 5 rows, M equals 1, 2, 4, 12, and infinity. There are no live links to other tabs. On exam day, you rebuild this from a blank workbook. The identity card at the top of the sheet says v to the t equals 1 plus I to the minus t. That is also 1 minus d to the t. It is also 1 plus I upper m over m to the minus mt. It is also 1 minus d upper m over m to the plus mt. And it is e to the minus delta t. The sheet does not compute a v column. The card is there so you remember every nominal symbol is just another way to write the same discount. From I equals 0.05, annual D is I over 1 plus I, which is 0.0476195. That is exactly cell D10, and every later ratio and Woolhouse formula locks onto that cell as annual D. V is 1 over 1.05, 0.95238095 from the identity card. Delta is the natural log of 1.05, 0.04879016. The sheet stores that in C14 as I upper infinity. Those 4 numbers, I, D, V, and delta, are the annual and continuous bookends of the table. Nominal I upper M is the interest rate quoted M times a year that is equivalent to the effective annual I. It is not I divided by M. The MTHLY effective piece is I upper m over m, and those m pieces must compound back to 1 plus I. Write the equivalence first. 1 plus I upper m over m, raised to the m, equals 1 plus I. That is the sentence you should have in your head before you touch Excel. Raise both sides to the power 1 over m. You get 1 plus I upper m over m equals 1 plus I to the 1 over m. Subtract 1, then multiply by m. That is the closed form. I upper m equals m times open parenthesis 1 plus I to the 1 over m minus 1. When m is 1, this collapses to I itself. As m grows, I upper m falls toward delta. On the interest functions sheet, cell C10 is plus B10 times 1 plus locked C7 to the 1 over B10 minus 1. Rows 11 through 13 are the same pattern with that row's m. The infinity row does not use this power. It switches to the natural log, which we will compute later. Nominal D upper m is the discount rate quoted m times a year that matches the same v to the t. 1 minus d upper m over m is the reciprocal of 1 plus I upper m over m. The sheet never types v in column D. It builds d upper m from the I upper m it just computed. Clear the reciprocal. D upper m over m equals the MTHLY interest piece over 1 plus that same piece. Multiply by m. D upper m equals m times I upper m over m, divided by 1 plus I upper m over m. When m is 1, this is ordinary D, I over 1 plus I. As m grows, D upper m rises toward delta, the same limit I upper m is falling toward. Cell D10 is B10 times C10 over B10, divided by 1 plus C10 over B10. Copy that down for m equals 2, 4, and 12. The infinity row abandons this quotient and sets D14 equal to C14. One more exam trap. Later columns lock annual D as $D10, the m equals 1 value, not the D upper M on the current row. Column E is the interest ratio, I over I upper M. Excel writes locked C7 divided by this row's C. For M equals 1 the ratio is 1. As M grows the ratio rises above 1, because I upper M is falling. Column F is annual D over D upper M. The numerator is locked D10. The M equals 1 discount, not the D on the current row. If you write D11 over D11, you will get 1 on every row and fail the conversion. Alpha of M is I times D over I upper M times D upper M. The sheet takes annual 1 and annual D from C10 and D10, the M equals 1 row, and divides by this row's C times D. Alpha of 1 is exactly 1. For every larger M, alpha sits just a hair above 1. Beta of M is I minus I upper M over I upper M times D upper M. Again, annual I is locked C10. Beta of 1 is 0. Beta then climbs toward about 1/2 as M goes to infinity. The tab stops at alpha and beta. It does not compute an empty CHLY annuity. On the exam, you feed these two factors into the UDD identity. A do upper M equals alpha of M times a do minus beta of M. That is why this tiny engine exists. Row 10, M equals 1. I upper 1 is 1 times 1.05 to the 1 minus 1, which is 0.05. That is the typed I. Excel's cached value is 0.0500000000000000000044, a binary float crumb. On the exam, you write 0.05. D upper 1 is 1 times 0.05 over 1.05, which is 0.04761,905. Cell D10 is also the annual D that every later F, G, and H formula locks onto. If you overwrite D10, you silently break the rest of the table. Both ratios are 1. Alpha of 1 is 1. Beta of 1 is 0, because I minus I upper 1 is 0. When payments are already annual, there is nothing to convert. That is the check row. If alpha of 1 is not 1, your locks are wrong. Hold the finished M equals 1 row. I upper 1 is 0.0500000000. D upper 1 is 0.04761,905. Both ratios are 1. Alpha is 1. Beta is 0. Remember this row. Every later alpha and beta formula reads these two annual rates. M equals 2. First raise 1.05 to the 1/2. The square root of 1.05 is 1.02469508. That is 1 plus I upper 2 over 2. Subtract 1 to get 0.02469508, then multiply by 2. I upper 2 is 0.04939015. That is official cell C11. Now column D, I upper 2 over 2 is 0.0246958. Divide by 1 plus that piece, 1.0246958, then multiply by 2. D upper 2 is 0.048199885. Notice D upper 2 is already larger than annual D, while I upper 2 is smaller than annual I. I over I upper 2 is 0.05 divided by 0.04939015, which is 1.01234754. Annual D over D upper 2 is 0.047619005 divided by 0.048199885, which is 0.987950004. Alpha of 2 is 1.00014879, just a hair above 1. Beta of 2 is 0.25617377. Hold the finished M equals 2 row. I upper 2 is 0.04939015. D upper 2 is 0.048199885. The interest ratio is 1.01234754. The discount ratio is 0.987950004. Alpha of 2 is 1.00014879. Beta of 2 is 0.25617377. Those 6 numbers are the live Excel cash, not rounded guesses. M equals 4. Raise 1.05 to the 1/4. The fourth root of 1.05 is 1.012272223. That is 1 plus the quarterly interest piece. Subtract 1 to get 0.012272223, then multiply by 4. I upper 4 is 0.04908894. Official cell C12. Smaller than I upper 2, as expected. I upper 4 over 4 is 0.012272223. Divide by 1.012272223, then multiply by 4. D upper 4 is 0.048493881. Discount has moved up again, toward delta. The interest ratio is 1.018554942. The discount ratio is 0.98196135. Alpha of 4 is 1.00018599. Beta of 4 is 0.38271733. Beta has jumped from about 0.26 at M equals 2 to about 0.38 here. That is the UDD correction getting larger as payments get finer. Hold the finished M equals 4 row. I upper 4 is 0.04908894. D upper 4 is 0.048493881. The interest ratio is 1.018554942. The discount ratio is 0.98196135. Alpha of 4 is 1.00018599. Beta of 4 is 0.38271733. Those 6 numbers are the live Excel cash, not rounded guesses. M equals 12. The monthly row you will use most on ALTAM. Raise 1.05 to the 1 over 12. That 12th root is 1.00407412. Subtract 1 to get 0.00407412, then multiply by 12. I upper 12 is 0.048888949. Official cell C13. This is the nominal annual rate convertible monthly that matches effective 5%. I upper 12 over 12 is 0.00407412. Divide by 1.00407412, then multiply by 12. D upper 12 is 0.04869111. Monthly discount is now very close to delta. The interest ratio is 1.02271479. The discount ratio is 0.977982234. Alpha of 12 is 1.00019701. Beta of 12 is 0.466508802. On a monthly annuity due conversion, beta is already about 0.47. Write those 8 decimal official values, not a 2 decimal guess. Hold the finished M equals 12 row. I upper 12 is 0.04888949. D upper 12 is 0.04869111. The interest ratio is 1.02271479. The discount ratio is 0.977982234. Alpha of 12 is 1.00019701. Beta of 12 is 0.466508802. Those 6 numbers are the live Excel cash, not rounded guesses. The continuous row does not push M to a million. Cell C14 is the natural log of 1 plus C7, which is ln of 1.05, 0.04879016. That is delta, and the sheet treats it as I upper infinity. If you try to type a huge M in column, V will not match this row. The formula changes. D14 equals C14. Continuous discount is the same number as delta, 0.04879016. That is the meeting point. I upper M has been falling towards 0.04879016, and D upper M has been rising toward it. The interest ratio is 0.05 over delta, 1.02479672. The discount ratio is annual D over delta, 0.975998687. Annual D is still locked D10, not D14. Alpha of infinity is ID over delta squared, 1.00019839. That is the ceiling of the alpha column, still barely above 1. Beta of infinity is I minus delta over delta squared, 0.508238186. So beta climbs from 0 at M equals 1 to just over 1/2 in the continuous limit. Hold the finished infinity row. I upper infinity and D upper infinity are both 0.04879016. The interest ratio is 1.02479672. The discount ratio is 0.97599,687. Alpha is 1.00019839. Beta is 0.50823186. Those are the official cached values from this spreadsheet. Here is the finished engine, every official cached value from the interest function sheet. Read across a row, I upper M, D upper M, the two ratios, alpha of M and beta of M. Read down a column and you see the pattern. I upper M falls from 0.05 towards 0.04879016. D upper M rises from 0.04761905 toward the same delta. Alpha stays glued just above 1. Beta climbs from 0 to 0.50823186. The graph is the same 5 official rows, not a fitted curve. Gold is I upper M falling. Cyan is D upper M rising. The dashed line is delta at 0.04879016. Infinity is plotted at the right as the meeting point. That squeeze is the whole story of this tab. On exam day, you cannot bring this workbook. SOA gives you a blank sheet. Type 1. Make rows for 1, 2, 4, 12, and infinity. Lock annual I and annual D from the M equals 1 row into every alpha and beta. The infinity row is the natural log, not a huge M. Rebuild this engine once from memory and the rest of ALTAM gets faster.